Hello, my name is Steve Pickrell. I work for R4 Contracting. I've worked for them for almost 20 years. This building behind me is 1021 West Hastings. It's a very complicated building. It's got an irregular shape. This crane that's mounted on the side of the building is a Jaso 180. It's a luffing crane. We purchased it from England. It's the first project in BC it's been on. We spent a lot of time and energy designing the way the crane is tied back to the building, which ties back through the beams and the slab. Because of the design of the mast, it's a lot of flexibility in locating where the tieback can go so we can make it work. A lot of planning goes into where a crane is located too. Like, you can't just, like downtown Vancouver, the proximity of all these buildings, there's a ton of research that goes into placing a crane, because even a rectangular crane, the jib direction, the way it climbs, the adjacent buildings, the minimum, maximum weather vane. Luffers are a little bit more complicated to place than a saddle top crane. This is one of the unique features of this crane. This tie-in can be placed anywhere on the mast except on the silver connectors, which makes it more universal for connecting into the slab. It's a typical tie, collar and brace arm configuration, except this one is extremely versatile because of it. It can be located in a lot of different spots, and we use a pretty unique brace arm too. They're adjustable, and normally they go into the face of the slab, so they don't even actually interfere with the window. But on this particular job, there's a curtain wall window system. So what we do is we coordinate the braces so they go in between the mullions. And with this kind of a mast section, we can do that. We can micro adjust these braces to get them to line up so they don't actually interfere with the windows directly. Like on some jobs, these brace arms would be where we're standing. And then they don't have the flexibility to place them, and then you might have to leave more windows out. Now we're only leaving like one section out, and the section they want left out. Like, we're actually planning, okay, I want these 3 sections left out, and that's what we're doing. We leave these 3 sections out. A lot of times when you don't have the flexibility in some cranes, they just go where they go, and then if you gotta leave 5 or 6 sections out or a chunk of mullion, that's just how it's gonna be, because that's how the crane works. Yeah. And the crane was actually picked because of that. And that was one of the main reasons we bought it, was the way it ties in, because we've had difficulties in the past with some older cranes, and we didn't want to have that problem in the future. Yeah, we went to Spain, and we went to the factory where they produce these cranes, and we talked to the engineers about some of the problems we had with some of the older cranes that are here in the city. They listened to us, and their cranes are good design, a very good design crane. We're bringing more of them in. We might bring another small fleet of them in the future. We're going to bring some high-speed luffers in for some of the new projects coming up. These brace arms are kind of unique to this crane. This configuration was designed to allow them to put as many windows as possible in, to minimize the impact to the window, the curtain wall structure. It doesn't slow us down, and it allows them to put as much window in as possible. So later on, when we're gone, it minimizes the impact of the work that's left to do. We had to coordinate these connections. They're actually a through bolt through the beam. This beam is a post-tension beam, so we had to coordinate these through bolts with the cables so that we wouldn't interfere with the cabling system. So it was quite a lot of work, but I have some good layout guys that actually drew all of that and allowed me to do this design, which helps Leadcore immensely with the windows. Because the more windows you leave out, the more work you got to do later. There's 5 tie-ins on this crane. Luffers require more tie-ins than saddle top because the forces on the mast sections are greater. They're a heavier crane. They pull more on the mast sections, so they don't freestand as high on standard mast sections. You have to get larger ones, which makes for a lot of climbing. We climb every 5 weeks, but it's working well. We have it fine-tuned now. It works right within our cycle, so we don't lose any time on the climb. We climb a little later in the day. We do a dual climb. We'll do a a tie-in and climb 2 mast sections, and then we'll come back another day, coordinate another day, and come back and put the last 3 mast sections in on another day. There's quite a bit of force. This beam, because it wasn't designed to take this lateral force, had to be reinforced. So the structural engineer and the engineer that was designing the braces worked together to reinforce this beam to take the forces, because these forces are like lateral forces. They're not, the beam wasn't designed to take those forces. It doesn't affect anything like our work, which is nice. It minimizes takedown too. Like our takedown will be a lot simpler. It's basically undo the bolt on the back, pull the rod out, and we're done.